Something that always baffles me is logistical systems, shipping industry, the complex web of marine vessels navigating the globe. It's just mind-boggling how they do it. And the future of that is, of course, digitalization of the marine industry. That could be even remotely piloted vessels. It could be autonomous vessels even. And of course, the pressure on the navigation technology is quite immense right now. Welcome to Allies in Innovation. My name is Mikkel Svold, and this is today's topic. And in the studio with me, or on an online link, I have two guests with me, and I have Peter Roelofs, who is the Senior Sales Manager for Vessel Traffic Services and Coastal Surveillance Services at Terma. Welcome to you.
Thank you.
And then I have Francis Zachariae, who is the Secretary General at IALA, who does, what do you actually do? What is IALA?
What is IALA? It's an international organization, and our aim is actually twofold. It's to harmonize and develop marine aids to navigation worldwide. And marine aids to navigation in IALA is a very, very broad definition. It is basically everything that floats on the surface to guide the ships, buoys, lighthouses, but it's also all the digital solutions that help the ships to navigate safely. GPS, communication, etc. And then it's also all the services from ashore to the ship, like VTS or weather information and stuff like that. So we have a very broad definition of aids to navigation.
And now, Francis, I want to start out by asking you, because the topic of this podcast is the digitalization of vessel navigation. When we spoke yesterday, just preparing for this interview, I was quite amazed or quite surprised that it's not already digital, because everything else seems to be. But what does this mean, the digital transformation? What's happening?
What's happening, Mikkel? Well, before I answer that question, would you just allow me to say thank you very much to Terma and express my gratitude for this company as being part of IALA for more than 25 years and has a strong support and commitment to our work. I think everybody in this business, and they know Jens Christian Petersen, who is really well known and my good friend. And he has participated in all the meetings of the VTS committee this last 25 years, which is a record in the membership of IALA. So thank you very much to Terma for your work and support to safety of navigation. And your question, Mikkel, is quite interesting, because why is it not already done? And, you have to be, I'm an old mariner myself, so you have to understand a little bit the maritime sector. It looks very modern and it is very advanced, but actually it is very, very conservative. The maritime sector is a quite conservative sector. And we like to talk about a technology gap between the maritime sector and other sectors of the world. The most natural one to compare with is aviation. But also, if you take banking, every other sector, I think I can say that the maritime sector, digital-wise, is a little bit behind. And if my wife empty our bank accounts back in Denmark, I cannot buy a newspaper with my credit card in Mumbai. So this is extremely digitalized, and that's not the case for the maritime sector.
Why is that?
That's a big challenge. Why is that? Well, I think it has to do with that we have sailed for thousands of years. I mean, we have always sailed. We have transported goods by the sea for thousands of years, and the evolution is going up, but it's going relatively slow. We learned to fly only maybe 100 years ago, and this evolution is going much steeper. I think that's part of the, and then again, it is a conservative group. I mean, we like development, but we take it easy.
And now, even though you do take it easy, and I'll take your word for that, but even though you say that, what is happening right now to the marine sector?
Yeah, some years ago now, many years ago, 15 years ago, so the IMO started a project called e-navigation. And that was really, revolutionized the whole maritime sector, because suddenly this e-navigation wave came into the maritime sector, and people realized that there was a desperate need to make the maritime sector more modern, more efficient, and also safer. Because if you look at our neighbor industry, aviation, they are extremely safe. I think last year or the year before was the safest year in the history of aviation. There were 0 accidents, no accidents at all for a whole year. If you look at the maritime sector, I just received the publication from EMSA, the European Maritime Safety Administration, and they have a whole chapter on accidents. And in Europe alone, there were 4,000 accidents in the maritime sector. So you see, it is not very digitalized. And I think what they have succeeded with in aviation is to eliminate the human error. And that's not the case in ships, because a ship lasts for 25, 30 years. And when you go on board a bridge of a ship, you will see it's very manual, actually. And we still lack this digital support to the officer on the bridge. How can 2 ships collide in clear weather, open ocean? I mean, it should not be possible, because the system, the GPS, knows where the ship is. The wonderful, perfect radar from Terma know exactly where the other ship is and can determine very accurate when they collide. And anyhow, it happens almost every day around the globe. So we need to digitalize more. Not necessarily unmanned. I know we will come to speak about that, but we need some digital assistance, some decision-making tools for the mariner on board. That will really help saving life at sea and protect the cargo and economy.
Do you think it could also have something to do with, I'm guessing that to pilot an airplane, you need maybe a little bit more vigorous training than to pilot your own little hobby boat. I know that if we're not talking super tankers, obviously that's going to take a lot of training, but
yeah.
But I mean, there are more private people on the sea than in the air, after all.
Yeah, but I mean, you still have the accidents with relatively large ships, and they are well educated. But for sure, in aviation, you take education much more seriously. I mean, if you just shift from one plane type to the other plane, you will have a certain amount of education and certification, etc. On a ship. In the maritime industry, it's not like that. I mean, you're a navigator, and then you can sail this ship and go. So that definitely they take education more seriously in aviation. That's for sure.
You talk about e-navigation. What does that mean to the shipping industry and to the maritime sector? What is e-navigation compared to
e-navigation was the idea that everything should be linked together in a system, so that all the information and all the navigation of the ship was linked together between the ship and shore and all the stakeholders. So when you left the port in Europe, all the way to your destination should be in a system linked, assisted by digital solutions. Let me give you an example. If a captain leaves a port in Europe, he has to arrive in, let's say, Singapore at a certain time, because the pier is only available at a certain time. Everything should be ready to disembark all his cargo, cranes, trucks, so on. So he needs to be there, very accurate timing. So what does the captain do? Because you can have weather conditions along this long route, different current against you, blah, blah, blah. So he will start on a relatively high speed.
Yeah.
If you are visiting your mother-in-law and you have to be there at 2 o'clock, you also start your car relatively high speed, and then you tend to slow down at the end.
For my sake, yes, but I suspect that depends on the mother-in-law.
But but that's exactly the same the captain would do, because he's extremely afraid of being late. That will cost the company an enormous amount of money. So he start with high speed, and then when he's safe, close to his harbor, he will slow down or even go at anchor in front of the harbor and wait maybe 1 day, maybe 2 days. If you come to Singapore with a plane, you cross over the entrance to the harbor and just look out the window. There are hundreds of ships at anchor waiting to get into the port. So with e-navigation, the idea is that you have the voyage all the way into your system. So when you start your journey in Europe, you already know from the World Meteorological Organization that there is a storm coming up 1 week later along your route in this area, and that will slow you down so much. So you can already, when you start your voyage in Europe, you could start on 12 knots, and then you can keep your slow speed all the way and arrive in time. That's just a small example of what e-navigation can do, but many other things. I mean, can make collisions, groundings. In avoiding all these things. Just small examples. It's much more, of course. It's a big idea.
Peter Roelofs, I want to turn to you now, because I see in linking these different systems together, I see a lot of technical complexity popping up. Can you maybe talk into a little bit about what makes this hard? Why is it not just already linked together, Peter?
Of course, the e-navigation is a fantastic thing, and having that information on a ship, as Francis indicated, a ship starting at high speed is very inefficient, because the fuel consumption is then rather high, and to make the voyage more efficient will definitely help. Like Francis said, weather, currents, whatever else comes up. But also knowing what is around you in other traffic. Of course, a ship has its own ways of determining that by its own radar, automatic identification system like AIS, and still accidents happen. People don't have the AIS on, or somebody is not looking at the screen. So those things happen. What we are seeing now, I would say about 10 years ago, companies got together in Europe to develop something called the Inter-VTS Exchange Format, IVEF. And that links VTSs, at least imports, together so that they can share information.
I think just for the new listener here, the VTS, Can you just give me like 5 words on what is a VTS, vessel traffic service? What is that?
A vessel traffic service, since Francis already made a link to the air market or the air industry, is like an air traffic control system for a port. The only difference,
it's centered around the port.
It's a port-based system.
It's not like across the Atlantic.
Correct. It is a port. So, for instance, the Port of Hong Kong has its own VTS. The Port of Rotterdam has its own VTS. The Port of London has its own VTS.
Okay. Thanks.
And it's and London is not connected to Hamburg.
Gotcha.
Yeah. So they're not interlinked. And so having said about air traffic control, ATC and VTS are similar, but they're not. So in an air traffic control system, the air traffic controller will tell the pilot of the aircraft what to do.
Mm-hmm.
In a VTS, the captain of the ship is always the ultimate responsible person. So he can be given advice, but he can never be told what to do.
Gotcha. That's a big difference.
It is a big difference. And so a vessel traffic service in a port. Basically, the original intention of the start of it, and I think it is somehow assumed that the Port of Liverpool in the late 40s was one of the first ports to have a system to sort of monitor and advise the traffic, and was also one of the first ones to use radar in the system. Albeit in those days, it was probably like a ship's radar on a stick somewhere on shore. So it was very rudimentary compared to what we have now. But the main reason for a VTS is to contribute to the safety of life. The safety of life at sea as the ships approach the port, to assist with the pilotage. At a certain moment, the pilot of the port will board the ship so many miles before the ship reaches the port. So again, the captain has an advisor about the local conditions. So as I said, safety of life, safety and efficiency of navigation is the other main thing. And as we know, efficiency becomes more and more important because time is money. And safety, of course, is also super important. VTS also is there to protect the maritime environment. But we also see more and more that VTS, because the VTS is operated by a port, is now looking at other things. The security of the port. Can that be linked into it? And as Francis said, is the berth available? So they have port management systems that link to the VTS. So everything plays together harmoniously. And on shore, it is now becoming very much digitized and automated. The vessels are the sort of old-fashioned outlier.
Okay.
Did that answer your question, or did I just go off on a tangent?
No. I think it did a little bit, at least, because I still kind of need to know, what does it take for, Francis, you talk about when a ship goes from, say, whatever, London to Singapore, along that way. That's a long way. Along the way, what happens? What are the check-in points with the radar system? What would it take to have that whole journey mapped out?
I think you point exactly at what is the challenge here, Mikkel, because I think the technical development, the technical solutions are there. I mean, we have all the technical solutions we need, but it is the harmonization that is really the main problem. We normally say that everybody screams for coordination, but nobody wants to be coordinated. So that is one of the problems, because we have all these local systems. Peter mentioned that Port of London, Port of Hamburg, VTS is also in congested waterways. All the straits in Denmark have VTS. The Malacca Strait has a VTS to guide the ships to, and all these systems are delivered by different companies. And they all have different data product specifications. So the challenge of harmonizing the data and the data product specifications is immense, and it's huge, because who should be the dominant system? And we have the problem in Europe, in the European Union. For many years ago, we decided to make a single window. So a one window shopping, so that the ship should be able to take all the documents, custom, crew list, everything from one place. And it has been just proved to be so complicated, because the Danish government has one system, the Dutch government has another system, and who should change their protocols to the other. So I think actually harmonization between all the stakeholders is an enormous challenge. And for that, we need the international organizations. You have IALA, you have IMO in London. You have IHO, very important player, IHO in Monaco. They make what they call the S100 data product specifications. And this is a global product specification for all the digital solutions. IHO are responsible for S100 and IALA is responsible for S200 that has to do with H2 navigation. And when this system is globally harmonized, then we have data product specifications that the companies can start manufacture using these specifications. But it's a very complicated area.
And Peter, would you be able to just swap over protocols to some other standard? Now you represent obviously someone actually producing the radars.
We produce the radars, but not the complete VTS system. So we're just a very small cog in the whole apparatus, so to speak. But the IALA is very clear in providing guidelines to manufacturers about the standards that should be used in the VTS. We ourselves use a rather open protocol. And there's multiple interfaces to a radar to connect it to VTS A or B, depending on the manufacturer, and they can change because they develop themselves as well. One of the standards that we use at the moment is Eurocontrol's Asterix data exchange, which is used for the radar video that tracks the plots. And so we're rather open in that. Most manufacturers will have to start doing that. And most of these protocols are purely digital.
But it seems there must come also a push from both, of course, the ports to harmonize, and of course also from the vessel owners, because both the ports and the vessel owners, they will be interested in efficient planning, efficiency at the port, just to get a higher throughput and to get, well, more goods delivered on time, save cost on fuel, things like that.
Yeah, there's an enormous push from the ship owners because the IMO in London, they agreed on a greenhouse gas convention that the ships should be carbon neutral within 20 years, I think, or so. And that has given an enormous push towards alternative fuels, because if you can start to use nitrogen or alternative fuels, then you have solved the problem. But the problem is that these fuels are either extremely toxic or they have to be stored in minus 250 degrees. So it's not easy to make this. And a big study that we saw suggests that digital solutions, the solutions I alluded to just before, can save 38% greenhouse gas if you make these efficiency in harbors, VTS, just-in-time arrival, weather information, all that. You can save 38% of the fuel.
But Francis, does that also mean
enormous?
Does that also mean saving 30? So do you say 38% fuel? Are those equal or close?
Yeah, I think it's close. I mean, it can save 38%. It can reduce the greenhouse gas 38%. I don't know if that's exactly 38% fuel.
No, but my point, of course,
in autonomous ships, Francis, you then take the crew of the ship.
Yeah.
How much does that save?
It does not save a lot. I mean, I heard from some of the ship owners that we work with that in a big container ship, the crew is only 2 to 3% of the cost of driving the ship. So what you take away in autonomous ship is you take away the cafeteria and the rooms, etc. And so you can have a little bit more cargo on board, but it's minimum, because a very, very big container ship with maybe 15,000 containers, they have a small crew, 10 people. I don't know how much, but the crew is today very, very small. And we made this big study about unmanned and autonomous ships last year in IALA, because our members were concerned about how to prepare for these unmanned ships, VTS. Do you still need buoys at sea, steel buoys at sea, lighthouses? And we made a big study, and the conclusion was that big ships, I mean big container ships, passenger ships, tankers, etc., will not be unmanned for the next 20, 30 years, because it's high-risk ships, and the crew doesn't cost a lot. I mean, it's not a big burden for the ship owners. And also the crew, they do not sleep all the way from Rotterdam to Singapore. They actually work. They repair the ship, they paint, they do maintenance. So all this work that is done on the way should then be done in harbor, where the ship would have to stay at the dockyard. So this unmanned solution is not so easy. And our conclusion was that it will not appear the next 20, 30 years in a big scale.
And of course, a ship is connected by a very thin virtual string.
What do you mean by that?
If it is autonomous, it will have to use satellite link to connect to whoever is controlling the movement of the ship. How secure is that? Can that be hacked?
Cyber, yeah.
And exactly. And if something happens with the ship, engine fails, rudder gets stuck, name something, who's gonna do something? But if that link fails, what's the ship gonna do, and who's gonna fix it? It's in the middle of the Atlantic.
I think it's actually quite interesting that you don't see the push towards automation and crewless ships, because that's quite different from what you see in other transportation sectors or other. But I guess when you transport 15,000 containers at the time, 10 people.
Don't misunderstand me, because the automation is really important, as I mentioned. If you talk about MAS, as it's called, Maritime Autonomous Surface Ships, there are 4 categories. One is a normal ship like today. Number 2 is digital assisted navigation. So you have digital assistance for the navigator on board the bridge. That's something I support strongly, because that could eliminate some of the human errors. And number 3 is remotely navigated. So you have somebody ashore driving the ship. And number 4 is completely autonomous. So then the ship will make its own decisions and sail completely autonomous.
And so I think, how far down the level, how far up the ladder do you think we'll go?
I think we'll go all the way eventually. We'll go all the way. I think so, but it will take more time than we thought a couple of years ago. We talked about, well, in a few years, all the ships will be unmanned. No, they will not. I mean, there will be a mix of manned and unmanned ships for the next 40 years. So we have to keep everything we have today, and at the same time we have to prepare for the future. But if you speak about large ships, big container ships, ferries, tankers, all these kind of things, I think number 4 and also number 3, I mean, on no crew on board, will take time. It will take 20, 25 years from now. I think, like Mikkel, you say the pressure in other sectors. Yes, we talk about driverless cars. But do you think it will happen tomorrow? Do you think whole Copenhagen will be filled with cars without a driver tomorrow?
I don't like driving, so I hope so.
I actually
think it's so boring.
I don't think so. I don't think so. I'm afraid
I would think twice about jumping in a taxi without a driver.
Oh, I wouldn't.
It would take years, Peter.
Yeah.
Well, probably you're right. I think just our time is nearly up, but if you were to do like a to-do list or a checklist of the things that you think is the most important to get done now to get this agenda pushed forward, the digitalization of the marine sector, what would those 2-3 points be? Peter, do you want to start this one? What's on your wish list?
Well, the digitalization of the whole marine sector is not sort of in my world. I have a very limited view of the VTS world, and the marine sector is of course a much larger part. What we are looking at is cybersecurity in our radars, and they're on a network. Each radar has an internet protocol and IP address on the network of the port. So one of our main things is cybersecurity, and our latest generation Scanter radars has cybersecurity embedded in it by design. And the second thing is looking at artificial intelligence that we're now bringing into the radar sensor part, where we look at the radar video and try to, by the use of machine learning, determine and classify what kind of ship it is that we're looking at. With the ultimate goal, of course, of one day saying that is that ship. So this is without the ship actually on a beacon like AIS telling us what it is, have the radar determine what kind of ship it is. And we're making great progress. Being lucky enough in Denmark to have a nice stretch of waterway where everybody needs to participate in the VTS, the Great Belt, Store Belt, and having a number of radars there, taking that data and basically teaching the machine about these classes of ships, where you now have the possibility of the thing saying, our radar with the added boxes, saying, yeah, that's a sailboat, or, that's a tanker. We want to then drill deeper into it and determine what kind of tanker. And so go deeper and deeper into that. And that's one of the very interesting things that we're working with, because that can then be fed into a VTS system and give it a helping hand. And if somebody is reporting wrongly on an AIS, it will then definitely jump out that things don't match up. So that's the kind of automation that you can bring into a system to assist the VTS operator. And yeah, we're talking about autonomous ships. Would we get rid of the VTS operator? No. You always need a person in the loop. So somebody can jump in when something is not quite right. But give them the tools and use the digital technology to make it better.
And Francis, what's on your checklist?
What's on my, at least three things, Mikkel. It is that the international organizations and the concerned stakeholders, they need to work closely together in a spirit of trust and cooperation to find these global solutions to the digitalization, because before we have global solutions, nothing will work, because shipping is truly global. I mean, ships go all around the globe, and we need global solutions. And then I think I talked about harmonization is key to success, because before we harmonize all these solutions, nothing will work. We need to agree and accelerate the work on a maritime connectivity platform, just like the internet. We have some solutions in IALA, maritime connectivity platform that can host a register of all the services, so that the mariners can find these services, like the internet, like apps. And then the maritime connectivity platform needs to be able to, in a secure way, to transmit these services to the ship so they can trust them. And then we need the other harmonized solution, the S100 I mentioned, the data product specifications, so that the manufacturers can produce the same systems. We have other solutions, MRN, Maritime Resource Number. So all the H2 navigation has a specific number that is machine readable, so all the machines can read that. And then my last point is, don't forget the seafarer, the human being, because they need to be trained and they need to be ready for this transformation of the maritime sector. And that's an enormous challenge all over the world. So we talk about seafarer transform to e-farer. So they need to adapt to this, and they need to be trained to use all these new software equipment.
Yeah. Peter Roelofs and Francis Zachariae, thank you so much for joining us. It was really interesting to have a little peek into the realm of, I guess, maritime navigation and all the complexities and all the hard things that needs to be solved here. Thank you so much for joining today.
Thank you for hosting.
And of course, to the listeners out there, if you like this episode, give it a like, and of course, share it with a friend or a colleague or whoever you think might be interested in hearing this. And if you have any questions or anything that you think would be interesting to talk about on this podcast or on the show, reach out to us on podcast@terma.com, and that was podcast@terma.com. And I think with that, I think all that's left to say is thank you so much for listening.